The original title for this was What's New in Apache CouchDB 0.11 and 1.0. And the reason being is that 1.0 is not out yet, but 0.11 being the last big release we do before we ship 1.0. And there shouldn't be much functional difference between 0.11 and 1.0 as far as we're concerned. There's a few bug fixes we're pushing through, making things a little bit more reliable yet. But as far as new cool features that I'm going to show you today, they are both in 0.11 and 1.0. So this is mostly what happened since the 0.10 release, or what happened in roughly the last 9 months in the CouchDB development world. Hey, I work for Couch.io. If you want to check out what we're doing, go to this website. But that should not be the topic of today. This is me talking at AuthCon. I'm doing the gesture right now, but you can't see it, of course, because that's not a video screen. I'm trying to be funny here. I'm not going to AuthCon this year. It's too far away, fortunately. A little bit about me. I'm a core CouchDB developer. I'm the co-author, together with Chris Anderson and Noah Slater, of CouchDB, the definitive guide, which we did for O'Reilly. And I got to point out that the O'Reilly folks were so kind enough to allow us to publish the book under Creative Commons license. So if you want to read all about CouchDB, all you need to do is go to books.couchdb.org and read all the book. We don't mind if you buy a paper copy of that and show O'Reilly your appreciation, and that they allowed us to do an open source book. But if you don't want to, you can just read it all online. Yeah, more about me. I work on all things web. Thanks, Marcy, for the link. I see that in the chat. I keep an eye on the chat. I gotta announce that. It's not yet 100 people yet. I wonder if we can get to 100. I also wish everybody could say hello or something to me, but alright, this is a one-way conversation. So let's read. Oh yeah, it's me. Applause. Everybody cheer. I wish I could hear that. It's not. Damn it. I keep losing my mouse pointer. It's kind of annoying. Can't really do anything right now because things look stuck. There we go. Yeah. I do love Flash a whole lot. Yay! Great, thanks. Hey, that worked. Nice. People are cheering in the chat room. That's really nice. Oh, hey, I put up an agenda for you, which I'm going to talk about today. Those of you reading our blog may have heard about these topics, but I'm going to talk about a little bit more detail on that. We're talking about URLs. Anybody here who has been developing Couch apps, which you learned in the last screencast and in our book, know that the public-facing URLs you see are not the most pretty ones. And as application developer, we're back-end developers, so we don't care about the URLs really. But we're proposing that people build real front-facing apps with this. And application developers do care about nice URLs, and in the last major version, we put in 2 features that allow you to make really nice URLs and have full control over the URL space on top of CouchDB. This is really nice. Next up is views. That's the powerful query engine that powers CouchDB. The powerful powers, yeah, a lot of power in there. Everybody, no, not everybody, a lot of people ask what joins are about or how to do joins in CouchDB, and then they read somewhere else that joins in these NoSQL databases don't really work, and I'll go through several examples of how to get things that you get out of a join in a relational database. There's a small tidbit in there about raw collation, which is really about speed. Next big topic is replication. There's a bunch of features in there that's really cool. The first one is really a small tidbit again. The second one is really nice for deployment stuff. I'll get into that. Filters is really cool to build large-scale apps or really just smart architectures. And then authentication. I wish I had more time to talk about that in detail, and I guess we should think about making a separate screencast for authentication. So I'll go through the basics of how authentication works in 1.0, but I won't go into too much detail towards the end. Sorry about that. That is not as thorough as I thought I could make it. But a preview nonetheless. So let's see if I can advance things here. My mouse pointer is gone again. Now I see a beach ball. Alright. More beach ball time. Right. So the first thing we talk about is URLs. Talked about that. Oh, that's a good question, Jonathan. I shouldn't get distracted by the chat. Like, damn it. I grew up on IRC basically, so when I see a chat room, I gotta look at it. Hey, Nitin, Ben, it's all there. Cool. I'm waving to you guys. Oh, sorry, I should stay on track now. Getting back on the agenda. So URLs, rewrites, and virtual hosts. That's what I'm talking about. Now, so I hope you've all seen how to deploy a Couch app, which is the Couch app script that you get from by installing easy install Couch app or easy install Couch app, and then it tells you that the Couch app got uploaded to your CouchDB, and then the final URL at where you can access your CouchDB. And this is a default, a very simple app. Later I'll probably put that up on GitHub to show you. If you're on example.com and then in the database DB, and then your app is called app, it lives under _design app, and then you have an index file and it's index.html, and that's the first URL that your users look at, or you have to point your users at to use your app. And that is not the prettiest way of doing this. It gets the big fat ugly stamp here. If you're using CouchDB in a traditional way, as in a 3-tier architecture behind say Java, Rails, PHP, Django, or other Python stuff in the backend that nobody ever sees, the URLs, you don't have to worry about that, but still making URLs prettier for you won't hurt, as they won't hurt performance. But if you do user-facing apps right out of CouchDB, and we encourage you to do that a lot, then you don't want these ugly URLs. So what we want is have our app to be available at example.com/ the root or the domain, and then say we have some articles. I'm just making stuff up here, and then we want to go to an article, what's new, and to be able to see what's in there. To see what's in there, and then there might be some tags, a list of all tags, or specific tags that we want to link to, and I'll show you how to get there in a bit. Oh boy, everybody posts this email. I'm Jan at CouchIO in case you want to talk to me. I screw the other guys there. To get there, to get the nice URLs, we need to go through 2 steps, and they're all intermingled. I start with rewriting, quickly show virtual hosts to complete the package, and then I go back to rewriting to show you more details. Hey Claire, what up? Wish you could sing that rap song again. I should really not look at the chat room. So the first step is rewriting. So let's say your CouchDB installation sits at server.com, as opposed to example.com, where we want to have the final URL later. The database we're using is /db, just as an example database. You can use any other name, of course, if you want to. We have an app called app, and the design document for that app is stored under _design/app. The start page of the app again is index.html. So the full URL again that we want to go to is http://server.com/db/_design/app index.html. I forgot a few slashes in there, and it took a whole long time to go through all that. So there's clearly usability issues. Somebody suggests I should go full screen. That's when I mark. It's a good idea, but probably shouldn't do that because then I can't look at the chat, right? So the first step to get short or nicer URLs to make them longer. That doesn't sound that it makes a lot of sense, but it's a very it's a clever principle. It's very clean, you'll see in a bit. What we want to do is to point /db design app index.html to another URL inside CouchDB, that is /db underscore design app underscore rewrite slash. Rewrite, the underscore rewrite handler is a special handler inside CouchDB that allows you to define any, you guessed it, rewrites. And to see how that works, we have our index.html. We have a very sophisticated application here that says hi to everyone. Everybody else say hi. I want to see about 106 highs in the chat room now. Also crashing the system, I guess. Jonathan, this is, I'll jump into, oh, that's a lot of highs. Okay, Jonathan wants to know why CouchDB is written in Erlang. I'm happy to answer these questions at the end. If you prefix your questions with a Q, the O'Reilly folks will keep a list of all the questions. I can reply to them later. Like, doing that within the talk that is about something else right now might be a bit distracting. Oh, Jesus, everybody's replying hi. That's really cool. Love you guys. All right. So there, we want to see that hi under example.com. Just keep that in mind. To do anything in CouchDB, you create a design document and put some JSON in there to see some JSON in there to tell CouchDB how to behave. And in this, by the way, can you see my pointer? If I use my, I don't think you can see my pointer, right? Right. So you see a design document here that has an ID. It's design app that defines the name of the app, and then this is a special member rewrites, and CouchDB will recognize this special member to, if it gets a request to the underscore rewrite handler of the design document, we'll look into there for rules to redirect. And the rewrite's JSON structure is an array or a list. You see that by the angle brackets, and then it's a list of objects. And the objects always look the same. They have a from and a to field. There's a few more there that I'll go through later. But the simplest example is we want to redirect from slash, which is the from is always relative to db design app underscore rewrite, to index.html, which is always relative to the design document itself. So if I were to go to the URL db design app index.html, that would be a regular CouchDB API request requesting the index.html attachment of the design document. That's just regular, a regular URI, and we want to have that. We want to get there. So that's the to part. We want to get there from rewrite slash. This is why we put the slash in the from. I'll show you in a second how that resolves. If we now push our Couch app into CouchDB, it will still give us the old URL because we haven't changed any of that. And if I go to the old URL, you'll see that I'll go in on my browser 127.0.0.1.5984. That's my local host. Database design app index.html. This is the plain old CouchDB API request I get back. The index.html page. But now if I go to db design app underscore rewrite, I also get my index page because of the rewrite handler I defined on the previous slide. I hope that made a little sense. So far. So that is pretty easy. So that was a run through how that works. Let's have a look at how that looks on the CouchDB side. This is the run log, or the CouchDB's log file that you can find on your system. I enabled debugging that you see in the front, the like grayed out front that says debug in brackets. You don't see that in normal operation. Right, Nikolai, rewrite is still ugly. I'm getting to that. You probably didn't get the setup where vhosts will fix that. So the first thing you see, CouchDB gets the first line. Make a GET request to db design app rewrite. It sees that, and then 3 lines lower, 4 lines lower, it says rewrite to where the actual index.html file is or lives, and then make a GET request to that. This is internally CouchDB turns the request we just had into just another request. It's sort of recursive. And if that would, no, I guess it's not recursive, but it is like one level recursive. You can't like loop through rewrites because that would be crazy. And then you see at the very bottom there's a GET request that has been done to the index.html file and has a status 200, which means everything went fine. So that's pretty good. So now we have everything. We can link to everything inside CouchDB into the full API from design app underscore rewrites, which is really cool, I think. But it's still ugly. Nikolai is totally correct there. It's not really well. Doesn't really look any good. So we have enter virtual hosts, and frankly, a little bit about the history of all this. We've been trying to make nice URLs for CouchDB for at least 2 years, and we didn't figure out how to really get there until Benoit Chesneau, one of our committers, he really wanted to have nice URLs, and he kept writing proposals and code on how to make it, and we always figured out one way or another that is not a good idea to do it that particular way, until he came up with the current solution that we just showed you. I just showed you, which is the right solution, the CouchDB way. But there were still ugly URLs. So he would be using the rewriter behind an HTTP proxy like Nginx or Varnish or something else that allowed him to map a virtual host, say example.com, to that rewrite URL. So users would always hit the proxy. The proxy will make the request to CouchDB under the ugly URL, but the ugly URL would always be hidden from the user. That worked pretty fine. The only problem with that is that you have to run another piece of infrastructure. You might not want to have an HTTP proxy running. You may want to have one. It's pretty cool to have one. You can do all sorts of tricks with it, and CouchDB fits right in because it just speaks HTTP and makes a lot of sense to do so. But you have to set it up. You have to monitor it. You have to do software upgrades and all these stuff. It's just another piece of infrastructure you need to handle, and it adds complexity. And so we tried to figure out how to get that embedded into CouchDB, and when we started thinking about how virtual hosts and in traditional web proxies or web servers work, we found that it's pretty easy to emulate in CouchDB. So enter virtual hosts. What we want to do here is map http://example.com/ to DB design app rewrite, to our rewrite handler. So all the requests going to example.com go to the rewrite handler, and whatever comes after that domain should also then go after the rewrite domain. So the rewrite rules can actually check the different URLs and route it particularly to the particular API endpoint of the proper API. To configure that, we just use CouchDB's config API. I'm showing the last line here, curl exput. How to do that on the command line using the config system. You could also use Futon to add that. All you need to do, or your ini file for that matter, all you need to do is create a new section called vhosts. In that section you need to create a new entry, example.com. If you're running on a separate port, on a different port than 80, you need to create example.com : and then a port number. And then you need to add a proper string value as the target inside CouchDB. Mashiach, I'm getting to the wildcards in a bit. The notation here is a bit weird because CouchDB expects a string, and if we would just use double quotes, then the shell would quote them away, or would use them as a string and would not pass them on to CouchDB. So I have single quotes around double quotes, which is why we have the funny triple looking quotes here. You'll figure that out when you do that. So with this, I can now curl example.com and get my index.html, and I think that's pretty nice. If you look at the run log for this, we see that the debug output shows us that it found a vhost target, and that our target is our rewrite handler. And the next section shows us that the rewrite handler gets triggered or gets requested. A few lines further down, we see the rewrite handler checks that it hits /, and and slash should be redirected to index.html, and now it gets the index.html back to the user. So we have pretty URLs for our index page. I highlighted another thing in line 1, 2, 3, 4, I think. It's the host example.com. This is where CouchDB does a very simple match between the HTML request header host, which is required for all HTTP 1.1 requests. It isn't required for 1.0 requests, but 1.1 all have them. And HTTP 1.1 was defined somewhere in the mid-90s, so I hope by now everybody is on 1.1. It's even older than IE4, rimshot. Just as a word of warning, you might want to use a vhost to secure access to CouchDB. So if you just like redirect everything appropriately, people couldn't access your CouchDB in the way where you would have an open couch. So that in theory will work, but the problem is that if you would send an HTTP 1.0 request, CouchDB still replies as an HTTP 1.0 server, and could not execute the vhost, and you would have a regular CouchDB there. So the vhosts are not a security device, just so you know. They are for pretty URLs. They're for looking for the looks only. Don't use them to make things secure, because that's not how they work. Thanks, there's even a rimshot in there, just in the chat room, that I shouldn't be paying attention to. I should really become a radio host. Hey, I want applause for this really cool demo, how you can make arbitrary nice URLs. Let me drink a sip of water while we. Sweet. All right. Let's see. Next page. Waiting for the spinning wheel of death. Again. There we go. More rewriting. Here are the wildcards. Now, we added a new rewrite. So I collapsed the first rewrite we just talked about to the first line. So we have enough space on the slide here. It's just the regular from/to index.html, and added a second one. And this is how you see you add more of these rewrite rules. Just add a comma and another object that has a from and a to. And now what this is doing is you see a special notation with a colon. URLs usually don't have a colon except in the port part. I don't know if the colon is actually forbidden in URLs, but nobody's actually using them as far as I'm concerned. So ID here is matched against the wildcard. So if we have a request coming in to /whatever, then ID inside the rewriter has the value of that ID. Yeah, I said that with a port just in. I hope you got that all there. The to part then can reference that ID again, and in this case we're forwarding or we're rewriting the request to a show function inside CouchDB that renders a document into something else, and we do just show some HTML there that we have in the JSON. I'll show you in a second. Yeah, Benjamin, that's a very good idea. We should write a Couch app that is this conferencing tool. I would love if any one of you would be working on that. It would be very much appreciated. So let's see how this works in practice. Let's see if I can get my pointer back. Right, that's the next thing. We have a small show function. I hope you all know how show functions work, because we covered them in the last few screencasts, and they're very easy to find in the book as well. What this is just a brief transformation function that takes a document as input and sends an output back to the client. So what we do here is check if the document has a field called body, and if it has that, we'll send that body back to the client. This is our example document. It has an ID called what's new. This is our URL slug. We'll just work with that in a bit for a while. And then we just have some HTML in the body. How that HTML got there, we are not covering today. This could just be Markdown. The show function could on the fly transform the Markdown to HTML. It doesn't really matter. This is just for example purposes. So this document gets passed into this function. I'm going back here, and since it has a body member, that HTML just gets sent back to the browser. Fucking th. And sorry, I shouldn't swear here. This is getting recorded. Sorry, mom. The browser should just get HTML rendered and see whatever we had in this document. Very easy, I hope. So if we run this, go to /what's-new, and remember in the rewrite that's where we had :id. That gets mapped to the document's ID, which then gets rewritten to the show function with the document ID that we now see here. If we run that in the browser, we just see nicely rendered h1 and in the browser. I see another question. Can we pop that up to the question bar on the right that you don't see but we are? I can answer that later. About is it good to store HTML code as value, not as attachment? This is just for example, just to show how that works. You can do that. You don't have to. There's different trade-offs back and forth. So I'll talk about that. I can talk about that later. I'll go through more stuff in the rewriter, which is really neat. So I'm not showing all the explicit details of the show and list functions here anymore, but just the rewrite parts. You have to fill in the blanks, but I'm explaining how that works. So we have a completely separate rewriter here, and say we have a URL /tags :id. We want to be able to look at specific tags and to what that is like natural and nice URL. But inside CouchDB we actually we use a list function that transforms a view result that we query with the tag name that was queried through the URL. So our target is a list function. We called that cloud because we want to make a tag cloud, and then that queries a view called tags. This is all again standard CouchDB API. And now we can also add query parameters with a new member called query, and then just a list of key value pairs as we use them in the browser with a question mark, key equals value, ampersand, key equals value, and so on. So to query _list /cloud /tags question mark key equals the current ID that gets passed into the request, then we can that gets passed in there. So you can use these variables in the query parameter as well. Really nice. Even more rewriting. You can also bind multiple variables. There's also a star variable that you can put at the end to get just the rest of whatever, which becomes handy when resolving rewrite rules. But this just shows two variables that get assigned start and end, and inside CouchDB these things are called start key and end key, and that gets just rewritten. Why not use some established regex mechanism like HTTP's mod rewrite? Good question, Jochen. I will answer that later, too. I'll show more of the cool rewriting stuff. There's another member you can put in the rewrite object you put in there called method. So you can make a rewrite rule separate for every HTTP verb or method. So say you want to handle a put request. When somebody makes a put request to /new/ whatever name, you want CouchDB to call update function. Its update function, and pass in the query parameter name that we got from the URL that got requested. If somebody would make a get request, this rewrite rule wouldn't match and wouldn't execute. So if we would put another one in that matched a get, that would be executed. This is a good time to mention the execution order. The rewrite rules match in the order they are defined. JSON arrays or JSON lists preserve order. So the first rule that matches any given request will execute. If you have a more general rule later that also matches something that you already matched, that will never get triggered. That you might have to figure out why a certain rule doesn't match. It's just because you have something earlier. Something earlier that already matches that one. There's tons of questions. I'd love to answer them in a bit. There's a few more things in there, like the star operator that just binds all the rest, but you can figure that out from the documentation pretty easily these days. So this gives you really great flexibility to basically map any REST API onto CouchDB. Our own Jason Smith, who works on the CouchDB hosting platform for CouchIO, has this plan to build a WebDAV API using the rewriter and vhost, so that CouchDB would just behave like a WebDAV client. That needs a few additions, so you can, like, WebDAV defines more query methods like propget, I think, and options that CouchDB doesn't handle by default, so it needs to handle that. But that would be really cool thing to add. If any one of you wants to help out with that, that'd be a really cool thing. If you could just like mount a CouchDB as a WebDAV drive and then just edit the files on the WebDAV drive, I think that'd be pretty sweet, at least demo. I'd probably use that in production too. So that's pretty cool. Mount, good. Cool, that was the section about nice URLs. I'll go through the questions we had first, so we're done with that topic. The first question is about why CouchDB was written in Erlang. I'll leave that for later. Mashiach, I hope I pronounced that correctly, asks if there are any wildcards or other ways to generalize rewrites. We already see here the colon name variable. Again, there's also a star operator to just get the rest of the URL, which worked pretty nicely. So yes, that is available. Oh, sorry, sorry, I got the name wrong. But I'm sorry, really. Alexander Shireen asked if it's a good idea to store HTML as a value or as an attachment. Again, doing it either way works. Putting it in as an attachment is nice because the HTML gets its own URL. So if you want to directly reference that HTML, put it in as an attachment. If you use it, or the other way around, if you want to use the HTML inside a show function, you can't have it in an attachment because show functions don't have access to attachments, and that's it is on purpose. So we don't do that very deliberately, because JavaScript is very poor at handling binary data, and it will be hell of a slow and very expensive to do so. So we rather not give you the feature than allowing you to shoot yourself in the foot. So you got to figure out what your actual use case is to answer that question. Jochen asked, why not use some established regex mechanisms like HTTP's mod rewrite? Dude, I'm pretty good to okay with regex. Like, I can read them, I can write them. Mod rewrite, doing like one-off things always turn into 1-hour sessions of trying to figure out how it works. Enabling logging on that is really painful. Reloading a configuration for a specific vhost that I'm working on isn't really possible, so I always affect the rest of the Apache server, so I have to install it all locally so I don't affect my live site. It is very flexible, but I think it does too much, and we wanted to give people a declarative way of just describing. Well, I guess regex are declarative in a way, but still way too complex. We just want to use a simple rewriting mechanism or rewrite definition here that we keep expanding if we see things that you should be able to do. And there were a few changes between 0.11 and in 0.1, like the 11.0 doesn't have the binding variables with query parameter. 11.1 and 1.0 will have that though, so we added that by community requests. There's another question. Why not use a custom document such as config, similar to design documents per database, that contains all rules and configurations for the database to avoid rewrite? So the thing is that rewrites are defined by the application, so they need to live inside the application, because the application needs to know what the actual relative URLs are. vhosts are per server, so that's a separate thing that needs to live in the config API. Design documents keep all the data that belongs to a single application, so if anything belongs to an application, it does belong to the design document. The reason is that it can be updated atomically and that it can be replicated atomically. More question. How about more methods like get put at the same time? Good question. That might actually work if you comma separate put, comma, get to match multiple ones. I'm not sure about that offhand, but if that doesn't work, that's a really cool feature request for 1.1. If you would go to issues.apache.org/CouchDB, I think, you can open and a ticket to figure out if we have that or not. Dick Davies asks, does CouchDB support this yet? Not CouchDB, CouchApp. CouchApp is this tool that takes your files that live in a directory structure and turns them into a design document. So all you need to do, oh, thanks Ben for giving us the link to the issues. I'm sorry, it's Jira. Since the rewrites member is just another member of the design document, you just create a file rewrites.json and it works automatically. It's really cool. We only have 30 minutes left, so we started late, at least 10 minutes, so we have about 23 minutes left, and I'll totally talk about the other stuff. Don't worry about that. Cool. So, well, yeah, we'll do fine on time. I gotta drink a sip of water right now. I'm muting my mic, so don't worry about the silence. I'm back. Next up, views. Yeah, slurp. This is a quickie for speed. So by default, CouchDB sorts views in Unicode collation. So if you have funky characters like resume, which doesn't really fit the ASCII, and you need Unicode encoding, the correct sorting for resume, resume, and robot is as defined. And this is the correct collation order in America or in English. If you were to use a Thai script or Chinese or Japanese or any of these other languages that don't have the traditional characters that we're using, CouchDB will know how to sort them correctly according to how they are supposed to be sorted. You don't even have to know that. If your users put stuff in that needs to be sorted correctly, CouchDB will do that by the magic of Unicode, and that's really cool. And like I said, this is the correct collation order. You can put in an option into CouchDB to change the collation variant to raw byte collation. So CouchDB doesn't actually have to look at how to sort a specific local script, and we'll just compare the bytes of the file of the strings that you put in there. And for that, since the accented E in there is actually 2 bytes, and in the UTF-8 that lives inside CouchDB, it will sort bigger than the robot. So that is a bit faster, but not as correct. But if maybe you don't have strings in there, but numbers or something. Oh, I guess numbers aren't sorted by Unicode anyway. If you don't need that guarantee of speed of correctness, you can opt for speed. Mike's asking the obvious question: how much faster is this? You got to measure. It can be significant for your data set, but there's no general way of saying that. There is a a subsystem round trip that is avoided through raw byte collation, but the actual benefit you'll have to measure with your data and your views on your hardware. And I wouldn't even know where to start to make up numbers for that. So you gotta measure yourself. That said, you probably almost want the Unicode collation, so just stick with the defaults. If you don't, this is how you do it. This is a part of a design document. This is how you define a view. This is a test map function that just emits the 3 words. I had a document in there that had all the 3 words, and then added another option or another member in the design document under the view definition called options, and that's just another key value pair, list of key value pairs. There's a few more that already exist. This is the collation value raw, so CouchDB knows how to avoid the Unicode collation. Again, this is a quickie, just so you know, but we added that. I like that. Any questions for that, except how much faster? Nobody's typing? Cool. I'll go with the joins, everybody anticipating this. I guess a lot of you have read Christopher Lenz's blog post on CouchDB joins, which dates back to, I think, September, October, or November of 2007. It's been a while. So even back then, CouchDB could do what we put here in quotes, joins. And to get in there is this is just a personal rant. The first item, related data, has nothing to do with relations. So whenever people think they move off relational databases, they aren't able to find related data. That is, of course, bullshit, and I'm being very explicit about this. The problem here is that relation and related have, unfortunately, the same name. But if you do the proper research in Wikipedia, you see that relations is something that has to do with math and set theory, and related data is just stuff that belongs together, and that has nothing to do with math or whatever. So just so you know. Finding related data with CouchDB and other databases is extremely simple, and I'll show you how. It all boils down to know that how to sort stuff correctly in CouchDB. So we have 2 documents here. The first is a post, say a blog post about what's new in CouchDB. I wasn't very creative. Hey, there's a good discussion on the chat on what related all means. The second document here is a comment to that post. Say this is a blog situation where people comment. It's very simple. They have the comment has an ID first comment. It is of the type comment, and it has a parent field that has the ID of the post document. Very simple. There's the relationship between these. It's not a relation, a relationship. You know. My personal rant here. Now we create this map function for CouchDB, and this looks at all the documents in your database and gets passed every single one of them and works on each one of them. And then this just looks if doc.type is post to a certain emit. I'll go into the in detail later. If it's not, but if the type is a comment, to a different emit. What is the emits are, if it is a post, emit a small array, 2-element array with the document ID and the 0, and then nothing for the value. And if it's a comment, put in the parent field instead of the ID and the 1. That might seem hackish. This is what it looks like in the end if you query that. You see the query at the bottom. If you use a CouchDB view queries can have complex keys. So if you query for an array that has what's new and a second element, a null value that I could just leave out here, and an end key what's new with the empty object, which means it's sort of bigger than everything else. This basically just says give me everything that has a key as the first key what's new, and the result is what you see up there. The first row is the blog post, the what's new one, and the second one is the first comment. Now you read that result in, and then you have the 2 IDs in order of how to display a blog post and its comment. And if there were more comments, they would sort below this other one. So you would also have the right order there. So this is already a solution here. So the operation is you query that view and then you fetch all the documents related to each row. So that works pretty well, but we can do better. Another approach where see that in the emit, this is the same map function. The only change is instead of emitting null as the value, I'm emitting the doc in both cases. And that ends up with something like this. It's a bit more messy, but you see in value, CouchDB gives you the full document that we defined previously for each row. So you just query the view and have all the data readily available. The query is the same. It's really, really nice. The problem with that is when that view index gets created, each document gets copied wholesale into the view index, and that copying operation takes some time. Now reading this view is extremely fast. So you avoid many disk seeks and just stream data off the disk. So if you're not worried about view index time or view index size, use that for maximum speed queries. It's really, really cool. But you might not be in that position. So we go back to the previous one where we use null as the value, and but add a query parameter. So we use the same start key and end key, but we add another one, include docs true. And you all said, boring, this appeared in 010, I've been using this all day. That is building up to the next feature I'm coming to. So this case, the view result, each row gets a new value, or a new member. We still have key and value. Value is still null because we emitted null. The ID always gets carried over. And we have a new member called doc that appears if we do include docs true. Now what CouchDB does is for each row that is returned from the view, it makes a lookup in the database and fetches the document and inserts into the result on the fly on the way out. But this means CouchDB doesn't have to copy all the entire documents into the view index at query time. That makes it a lot faster to build the index for querying later. But this also means actual querying is slower because every view row makes a separate request to the database. It's still inside the database, but that lookup still needs to be made. So there's a trade-off between query speed and indexing speed. But you can make that up for yourself. But like I said, this has been there for 010. We can do even better. What does this look like? We changed the emits a little bit. So instead of inserting the full document, and instead of using include docs or using null, we emit as a value a document underscore ID with the document ID in both cases. Let's see what that looks like. I still query with include docs true, and this also gets me exactly this actually gives me the exact same result as before, which is interesting. But we can change our now if we can, this is the new part, if we now change our new knowledge that we can use the underscore ID in the value to fetch a document, I can show you something new. So say we just want to view a single comment, but then we want to quote, say, the last, I don't know, or we want to quote the full body text so people can see the one reply, but also what is being replied to. So this is a different scenario we want to look at. So we want to look at one comment now. This is a different view. So this map function only looks at documents that have doc.type equals comment, and then we, instead of emitting the value of the document ID, we'll use the document parent ID. And now this gets a really interesting thing. If we now query that with key equals first comment, so we get the first comment that we made, and add include docs true, CouchDB will automatically fetch the other document that was referenced in that view result row for you. So it gets the actual post type. So this lets you basically define foreign keys for fetching on reading. The same caveat with performance on include docs applies here too, but this lets you point to other places. This is a little bit similar to how links in React work, except it's just only one walk at a time. But this is the closest we can get to getting close to having real joins. So this is single query, single result, all the values you need. This is really really need. Let's see where we can go next. I really wish this had a preview thing for the next slide so I don't have to guess what's next. Hey, any questions so far on joins or raw collation? Sorry, Ben, that the audio is not too good for you. All right. Vote is asking how is that different from the old include docs. The old include docs would get the document that so a map function generates an entry in the view result, and include docs would automatically fetch the document that generated that one entry. That is how it worked before. But if you can also put an underscore ID into the map function, into the map result, and then CouchDB will fetch a different document for you that is referenced in the ID. So if you previously know that there's two documents that are related to each other, and you put the other document's ID in the document that it is related to, you can get the other one. Cool, got that. More questions? We'll take a sip again. Cool, no more questions? Oh, we can always do more questions later. Oh, somebody removed all the questions. There was another one about Erlang. People remind me at the end to talk about why CouchDB is written in Erlang. About replication, the first two are quick ones. The first thing here just shows you how to do replication. If this would be like a proper audience talk, I'd ask if anyone here would have done CouchDB replication and raise my hand and wait for everybody to raise their hand. And then I would ask if anybody here would think that CouchDB replication is pretty awesome, and I would hopefully see a lot of more hands. This is just how CouchDB replication works. Just, send a post request to the underscore replicate endpoint. And hey, I got raised hands. That's pretty nice. I like this chat room. And we just post a JSON object there, and it includes the source and the target database, and then CouchDB will do its magic to replicate from the source to the target. The first example is local database replicated to a remote database. Very simple. Now, in order for that to work, you had to go to the target database beforehand and create the target database in case it wouldn't exist. And if you wouldn't do that and you would issue the first command and the database wouldn't exist, CouchDB would fail with an error. That was annoying me at some point, so I created an option, create underscore target equals true, or is true, to tell CouchDB, hey, if you try to replicate and you can't open the remote database, try and see if you can create it first. If you can do that, fine. If you don't, report an error as usual. So this is a very small trick. I like it a lot, though. It just adds to the whole usability of the system. The next one is, we already talked about couch apps and deploying stuff. So I often use, we have a staging server that I can replicate my app to and see if everything works, and then instead of doing couch app push to the live server, I can just replicate from the staging server to the live server. That is because my connection to the live server is as slow as it is to the staging server, but the staging server is has a bigger pipe to the live server, so replication is a lot faster between these two instead of me pushing it. So what I want to be able to do here is selectively replicate stuff, and this CouchDB allows me to do that with the simple addition of a docs underscore IDs member in the replication object. So this time I'm replicating from a remote database to a local database, but I give CouchDB a bunch of IDs, and that is only design app, the design document that has our app, and the support document that goes with the app that I want to have. And CouchDB will do a full replication, except that it will only use these two documents. Give me the two documents here. Everything else is the same. You can do remote, can do local to remote, remote to local, or remote to remote, just as usual, or local to local, and limit it to a specific set of documents. This is really cool for deploying. Next up, filters. That is really, really cool. So this is a bigger one, so I'll explain a little more. Filters is something you can define in CouchDB again, in the design documents again. So this is a design document that has a new filters member that CouchDB then recognizes. And filters is an object that has a nested object, which is just a list of filters that have a name, sort of like map functions or list functions. And here you just have the raw JavaScript code formatted for you. In JSON there can't be the line breaks, should be /n, so \n. So it won't look exactly like that for you, but you can read it easier now. So what this function does is it gets, for each document that is supposed to get replicated, it will be passed to that function. And this function takes two parameters, the doc and the rec. And the request, is just the HTTP request object of the request that makes the replication attempt. So if I put any options in there and see that later, I have full access to that. And what this does now, this filter function is very stupid. I'll give you a reason why this is not as stupid. Is it looks if the document ID starts. Cool, there's actual error in that slide. So this should be char at 0 equals rec query starts with. I'm pretty sure that's where I got interrupted with a phone call earlier, and so I didn't fix it. I'm sorry about that. So let me quickly type how that one line should look like. If doc dot underscore ID dot char at 0 equals rec dot query dot starts with. This is what this line is supposed to be. I'll fix that later, of course. So Guillermo, I'll answer that question a bit. If anyone could put that on the notes, please. Thanks. So I'll just post to the line how this was supposed to look like. This just looks at the first character of the document ID that this is scheduled to be replicated right now, and it just gets compared to a query parameter that you can put in when you do the replication request that I show on the next slide. And if it starts with, say, the parameter is letter A and the document ID starts with the letter A, the document gets replicated. If it isn't, it doesn't. So this gives you a subset of all the data. Let's see. If we make this kind of request, it's just the same old replication request. Cool. From the source target, I'm defining a filter, and there's another option, query parameters, and as I starts with A. Now this A gets passed into the filter function as well. So this replication request will give me all the document whose IDs start with an A back to my local database. And Guillermo, this answers your question. If you have a database that has a username and pass, you just put it into the URL like this. If you want to replicate to a local database that has a username and pass, and the same goes for Lucas now, you just need to use the full URL to put the username and password in there. And then it just works as expected. I hope that answers your question. If you still have problems, let me know. Next up, let's see. Damn it. That. Alright. The next one is an authentication filter. I'll go into more auth later. What we do here is the rec object actually has access to an authenticated object. So if you remember the request I made here with the source and username and password, I can actually access the username from here. CouchDB will give that to me inside the rec object. There's an object called user context, and there's an extra space in there. See the if rec.usercontext.name. That gets populated with the name I put in the URL. So this would have Jan. And if there wouldn't be any, CouchDB would know, or I would know in the filter function, I wouldn't be logged in. So now I look for documents whose username is set to my authenticated name. So somebody else or me earlier put in documents with my name on it, and now I only want to get these ones that are mine. But I also want to make sure that if I replicate, I'm guaranteed to only get mine, and it's more like that others are guaranteed I don't get theirs. It's, of course, I can have other ones, but That's not good. So only if the request user context name matches the doc username inside the doc, I will get that replicated down. Again, if that's not the case, the filter function will return false and will not replicate that particular document. How that becomes useful, I'll show you in a bit. And there's how you query this. Again, I put the username and password in there to a local database, and I'm pointing to that filter. Now, to force people into, no, let's not go into that. Never mind. The only thing that you know that is guaranteed that if you were to use the wrong username and password, CouchDB wouldn't allow you to read that or to replicate there through that. Why is this particular one useful? Say we have something where there's a lot of messages in the system, and there's a shit ton of users, but not all users are online all the time. Say, I don't want to say Twitter because everybody uses that as an example. It's like any messaging system. So the messaging system has a big database called messages that has just all the messages. And then the messages have a recipient, one or more recipient addresses associated to them. Now, if a user becomes active or logs into the system, oh no, I go one step back. Each user also has a separate database inside CouchDB that is its inbox, his or her inbox. So all the documents that belong to that user are in there. So when a user logs in, the inbox needs to be updated. So we could just kind of set up replication with the user filter, like I showed you before, to only replicate the messages to the user that were directed to him. So everybody would just get the messages they apply to this. Will scale up to millions of users. CouchDB has been tested with millions of databases in it. So you can build a single centralized service that works a lot like Twitter on the basic messaging thing. I'm not saying this is an architecture that Twitter should use, because Twitter does a whole lot more, and their architecture is probably better suited to that because they have been working on that and I haven't, and I'm not an expert on how Twitter works. But this is a general messaging idea, sending messages to user inbox, or delivering messages to user inboxes, just as a general thing. So this is really nice. The other one is big cluster work. Well, you remember when I said I want to do replicate documents with a certain ID to a certain target, and it sounded a little bit stupid. Then this is why it isn't stupid at all. And the CouchDB Lounge sharding project benefits from this actually. I don't think they use it yet, but they will. Pretty sure. So say you have a sharded CouchDB where a quarter of all your data lives on a single node. This is the image on the top left with the 0, 1, 2, 3 ring, and all your the 0, 1, 2, 3 are CouchDB nodes. The whole ring is the entire data set, and it's always a quarter. And if you want to grow that, instead of adding single ones in CouchDB Lounge, you replace each node with another CouchDB Lounge, because lounges just look like regular couches, and you can grow capacity with that. And to split from a single database to 4 databases that have a quarter, you can just use a filtered replication that will just, each node just makes a replication. Give me a quarter according to our hash function that distributes our documents. Skipping a lot of details here. And thus easily prepare new nodes for scale out. This is really nice. JP Menz asked, millions of databases on a single CouchDB instance. Yes. Yes, that CouchDB has been tested with that. That works just fine. You run into OS limitations before into CouchDB limitations to see that. Dick Davies says half fractal cluster. That's exactly correct. We refer to that as fractal scaling, and of course it grows exponentially, and it's really, really, really nice. It doesn't have the logical ease of just add a box and then it will figure out what to do, which other projects do, and it's a totally valid approach and cool. But there's a lot of complexity that comes with just adding one box that needs to be hidden under the hood. We don't want to attempt that, and using fractal scaling is a lot simpler technologically. but a little bit more operation overhead. But that gives you fractals, and I think fractals are better than anything else, and I hope you agree. I think that's the two use cases I want to go to. The other one I don't have a slide for, I think, is Ubuntu One. I hope you all know that canonical service that uses CouchDB as desktop sync service that actually has hundreds of thousands of databases on their server. And using filtered replication, they can make sure everybody can only see what they're supposed to. I don't think they're using it right now, but they should pretty soon. So, any questions on the filtered replication so far? Waiting a minute. I see a few people typing. I'll wait for your messages. Yeah, drinks, correct. All right. I'll follow up. JP asks if Ubuntu has a lot of database, why filter replication? I'm not at liberty to discuss the technical details behind that, so you probably should ask the canonical folks. They are in the CouchDB IRC channel, and they're very open with talking about how that works. So you probably should talk to them. I'm sorry, I know more of that than I can tell you. I'm sorry. Nikolai, the replication by ID is much faster than filter replication. Depends on what you're doing. If you just want to filter out 2 documents, using by ID is a lot faster than filtering through all. But then finding the list of all IDs and posting them might be too big a task. So it depends on what you want to do. So there's definitely room for both of the approaches. The next one, and we're probably a little bit over time, is the authentication. And I'll give you a little overview of all the things that make up CouchDB authentication and how it works briefly, but I'm not going to into all the technical details. I think they're not. I wish they were alphabetically ordered, but maybe I don't. So the first thing is the admin party. CouchDB by default ships in admin party mode. Admin party means every request automatically gets executed as if an administrator would make that request, and that's extremely convenient. When you start out using CouchDB, you don't need to worry about any passwords and stuff. If you think that might be a security issue, it isn't, as so far that CouchDB by default only listens on localhost or 127.0.0.1 or home sweet home, and nobody else except you can connect to that. If you are on a multi-user machine, of course other people can access it, and then your distribution should make sure that you only can have, or you yourself or your admin should make sure that only you can access it. But if you're just trying out stuff at home or on your own server, there's no problem with that. You have to explicitly enable remote networking, and you can do that after you set up users and administrators. The next thing is database. The database in this case, CouchDB is also a database. So what's the database here? CouchDB is a database management system. It manages multiple databases. We already said there's hundreds of databases, thousands, a lot of databases inside a single server. We're talking about the single database inside a server among other databases. There's a user, a person, a logical, either a real person or an agent that acts on behalf of a person, but something that can authenticate with the username and password or token to describe or to ensure that it's really him or her. Then there's authentication, authorization. The one is proving that I am who I am. That is authentication. So if I give you my username and password and that matches the records you're having, I'm authenticated. Basics here. Authorization is just is the second part of the auth dance. Am I, after making sure it's me, I'm talking to you, am I allowed to do whatever I'm asking? There's also roles, which is sort of like groups. Which users can have roles, and then you can give permission on a wider granularity, and like everybody in this role is allowed to do X, instead of giving everybody the ability to do X. There's the anonymous user. If you have users defined in CouchDB, the anonymous user gets automatically assigned to every request that doesn't have any authentication information. So if you don't use login, any login stuff, then you are acting as the anonymous user, and there's also an anonymous role, and you can give explicit permissions to what anonymous users can do. So maybe anonymous users can post comments on your blog, but they can't create new blog posts, or maybe they can vote, but they can't create comments, something like that. You can make that very granular. Access control lists exist per database, and there is administration or database admin users, and there's database admin users. So I just said database admin users twice, right? So there's server admins and database admins. In admin party, everybody's a server admin. If we start adding admins, we can say this is the owner of a particular database. So we like to think, and everybody owns one or more databases. So I own my database, and I'm the admin of that, even though there's a server admin that has more rights than I have. As a database admin, I can create access control list for other users or roles to read and write from my database. Sketchy information here. There's also validation functions which can and will control if I can access or if I can write to a database. Validation does both the authentication or the authorization and the looking if my documents look like have all the required fields. There's basic authentication, cookie authentication, and OAuth in CouchDB. These are the three methods by which you can do authenticate. So basic auth is what you know from back in the day when you log in somewhere and this ugly pop-up window comes up in the browser, and you can put in username and password and authenticate to a site, and then it will let you do stuff. And there's no logout button, and it's really sucky. The way we implemented in CouchDB is that you don't have to get the ugly login window, but still use basic auth. It's really nice. There's also encrypted cookie auth. So there's a token that CouchDB sends to the client, which is encrypted, and only that one client can have. So if you can keep sessions open for a little longer than just for every request like basic auth does, where the client needs to do some more magic. Cookie auth is pretty secure, but I'm pretty sure there's ways to spoof that too, if you're really smart. The OAuth we implemented is two-legged OAuth. OAuth lets agents do stuff on behalf of the user without knowing the user's credentials. Say I have a website that maintains my Twitter favorites instead of Twitter, which has a sucky way of just for example managing my favorites. So I can tell that site, you go register with Twitter as the admin for my favorites, and then that app will redirect me to Twitter to confirm that that's true, and Twitter will authenticate and authorize me and the application to do that. And from that point on, the application can use OAuth to talk to Twitter on my behalf without knowing my username and password, which is really nice. Ubuntu One or Canonical are using this on Ubuntu, so all the desktop applications are acting on behalf of the logged in user to talk to CouchDB. So they are using a fully OAuth system on the desktop, so it's not tied to the web. This is the most interesting part here is the access control list and how you set them and what you can restrict with them. The most interesting thing here is that you still can't what you can do is define if somebody is able to read or write to your database as a role or as a user, but you can't restrict who's allowed to read a particular document. So if somebody is allowed to read from a database, he can read any document. And this might seem like, yeah, they'll fix it eventually. Well, we don't enable that feature, or we don't have that feature again deliberately, because it would be very hard to enforce when it gets to views, because then every view row would need to be evaluated if the particular user is allowed to see it. And if we use reduce in your views that creates aggregate values, you would unwrap this aggregated value and see if all the rows that build up that value were allowed to be seen by that user, and that doesn't really work or perform. So we're not doing that. Which is why we're pushing the idea of having multiple databases for lots of stuff. So everybody has his or her own personal database that includes all the stuff that he or she is supposed to see, and then people can replicate selectively to shared databases to share data with others. So they have an outbox and an inbox, and people could replicate into my inbox. They have a like Dropbox write-only kind of way to talk to that, and then I can look at that and selectively replicate stuff to my personal database to keep it there safe, and then delete it from the public one. But also I can publish to other ones there. So this is a much more Git kind of way, or much more distributed way of thinking, instead of having one monolithic database. This also allows to build very big peer-to-peer application. Scott is asking if that's related to Desktop Couch. Desktop Couch is the framework that Ubuntu, or that Canonical put into Ubuntu to have applications talk to CouchDB. So this is very much related. For Auth, just want to add that there's the full OAuth is called three-legged OAuth, where applications can actually go to a service provider like Twitter and say, hey, I want to act on behalf of that user. Please ask that user if I can do that, like in the example I quoted. CouchDB doesn't have that yet. You need to predefine which applications are allowed to use that, or use that CouchDB. Look for more questions. I think I answered all the questions that we have on the notes here. Very quick slide. So, oh yeah, what CouchDB comes with since 2011 is a users database where you can create documents for each user, and they look like this. The ID is freeform, but by default it's org CouchDB user :Jan. So you know the reverse domain notation, domain name notation, and then a colon with my name. We stole that from somebody. Has a revision like it's just a regular database. It's of the type user. It's of the username is Jan, of course, and there's a list of roles, and in this instance I'm an admin, which is cool because I can't do anything, but you can just define any other roles there. If you want to make your own roles, just put them in there and you can check for them later in the both the ACLs and the validation functions, which I'm not going to cover today. Nikolai asks if or when CouchDB 1.0 is going to be released. We hope to get this out in the next few weeks. So that is this is hopefully good news for everyone. We're working very, very hard to get the latest stuff that people are working on in, and it's very close. Since this is open source, I can't make any promise, since I'm not the only one deciding, but we're, like me personally, is working hard on getting that out. Jason is asking where's the password. You use there's a special API to talk to the to create new users, where you put in the password. If you query the user's database for a user, CouchDB won't see first. CouchDB hashes the password, so CouchDB doesn't have the plaintext password and solves that too, of course. But you can't query the password hash if you aren't an admin yourself. So this just gets omitted from this database, but from this document. But the hash is stored in the database and gets compared against. Next one. Oh yeah, I have another one where I just made up the ID, just so you see. Oh, okay, we're nearing the end, and I'm a little bit over time. I hope you're still good. We're doing Couch Camp on September 8th to 10th in the Bay Area, in Marin County, north of San Francisco. If you go to couch.io/couchcamp, we have a beautiful site put up for you where you can meet Damien Katz, the inventor of CouchDB, and a bunch of really, really cool speakers, and we keep announcing more speakers. I'll get to the next question in a bit. Thanks. To the online question in a bit. CouchCamp is a really cool way to meet all the CouchDB developers and a lot of enthusiasts, which really, really will be really nice if you all show up there and we can have a big party there. There's a lot of interesting talks, a lot of relaxation, outdoor activities, really nice conference for you. And it's like a summer camp. There is internet there, but that's about it. It's all about nature and relaxation and all about the CouchDB awesomeness. It probably won't have a live webcam. How lame is that? You should be there, really. Let's see. The question why CouchDB was written in Erlang. So a couple of reasons. CouchDB, one of the CouchDB's primary goals is fault tolerance. Whatever is going on, make sure that if there's an error, any sort of error with a single request, which always can occur because you can never be sure if there won't be any errors, but if one occurs, make sure that none of the other requests that are going on concurrently are affected. And Erlang was built to just solve that problem very, very well. The way Erlang works and the way you write it makes it very, very hard to write buggy software. So once you figure out how to write something, you're pretty sure it works across the board. So writing bugs for somebody who's like not a pro Erlang guy is really, really easy. Erlang is a functional programming language which has a bunch of features that, or by the nature of being functional, having no global state makes a lot less for a lot less buggy software, for a lot less lines of code, because you just don't have to be very explicit with it. If like I've been looking at server software for a long time. If you were to build any kind of server software that you want to be reliable and you don't want to worry about it anymore, I don't think there's any way to do that except there's many ways to do that, but the right way to do it is in Erlang. A lot of people get close or get some aspects of Erlang right, but Erlang gets all of them right, writing fault-tolerant server software. I'm happy to do another screencast on just Erlang, maybe. A few more questions. Previous screencasts, they are linked to from our blog and from the O'Reilly site. I hope the O'Reilly people or Anna can link to them. These, like the other ones, this one is recorded, so you can see the full video. Everything. Alexander is asking about OpenID. Good question. Haven't gotten around to look at it and how it fits into CouchDB yet. Final question. Right. I'll skip slides. I have a few more. I totally can't remember. Oh, it's a thank you slide. Thanks all for coming. There's like nearly 100 people. It was in the beginning. It was really nice to talk to you. Friend of a friend and SSL. Interesting. So thanks all for coming. It was big fun. I really want to do one of those again and probably do that on authentication. Next month, Chris we'll be talking about distributed replication, how to stop worrying about eventual consistency. Scott, my slides will be online. This entire thing has been recorded and the video will be posted on YouTube as soon as possible. What else do we have? Oh, there's an empty slide. I have yeah, okay, we're out of time. I had bonus slides in case we were short in time, but I'll show them the next time then. All right. So I think I'm ready here.
Thanks, Jan. That was, boy, I hear myself broadcasting. Hey, thanks, Jan. That was incredible. That was pretty amazing. And I also want to thank everyone who joined today. What a great group. It was a really fun webcast and very informational. And I hope you guys will all join us again. So if there's nothing left to say, then I'm going to need to close out the webcast room, and I'll send everyone a link as soon as the recording is available. I think you'll get an email probably later today that has the link to our survey. We'd really appreciate it if you would take the survey and give us some feedback, just so we always like to improve this. We know it's not perfect, but we're working on it, and we could use the feedback. And to encourage you, I will randomly pick 3 people to get a free ebook, so that would be great. And that's about it. No rap. No rap. I'm sorry.
Sorry, I'm not gonna rap.
Maybe I thought Claire was in here, but I don't think she has her mic turned on. She is the rapper. So thanks everyone, and we'll talk to you again next time. So adios.
Bye all.